Hey class, I appreciate you all bearing with me while I get through my sickness, and I apologize if you on this video hear me sniffling or I sound congested. It's because I am. But I wanted to create another walkthrough, this time for homework number 3, so I can help you get through the assignment without too much trouble. So much like we do for every other assignment, we should go ahead and create a new folder on our desktop. Call it something you can remember. Not that we're going to be using this name, but it's easy to remember, so call it Homework 3 or HW3. Next, let's go to the course website and open up Homework 3. We'll go ahead and download the Homework 3 file by right-clicking and selecting Save Link As. I'll go into my Homework 3 folder and the R file for Homework 3. Save. Okay, we can go back to the original course page. Okay, cool. Now we have our Homework 3 file and our R file. So let's open this up a little bit wider. So this is again worth 10 points, due May 5th, so next Friday. In this assignment, you'll be completing one whole problem using R. This problem covers topics in Chapter 11, which deals with the chi-square test. And importantly, please remember to copy and paste your R script as the final page of your assignment when you upload it. So the final page should be your R script. Alright, problem 1. Using the surveys dataset in R, which comes from the mass package, report a bivariate table for the relationship between sex and smoking. So we're going to look at our output is going to be a bivariate table, which we saw last week, what those were. And it's going to show, sex on one, either the row or column variable, and smoking on the other row or column. And using the surveys data. So much like we've called up the MT-CARS dataset or the US arrest dataset last week for our homework, the surveys dataset can be pulled into R, so we don't need to explicitly go and download an external dataset. However, we do need to load the mass package because that's where the survey dataset comes from. So let's open up R, but to do so, let's just open up our homework 3 R script, which is the example code that you can use. You'll see here that I've already loaded or typed out library mass, which will help us get that survey dataset. So I'll go ahead and run, and it was successful because we have no errors. Now, if we just type survey, it'll give us that survey dataset. Now, this is a dataset that asks questions from 237 students in a stats class. Asks their sex, which hand they write with, or the width of their hand, which hand they write with, when they fold their hand or cross their arms, is the right over on the left or vice versa, their current pulse, how they clapped, which hand is dominant when they clap or which one is on top, do they exercise, do they smoke, their height, and whether or not they gave their height in metric units like centimeters or imperial units like inches and feet. So this is great. We have this data set that we can use, but to make it usable, much like we've done with other assignments, we have to use the assignment operator and give it a new name. So here I just have the word survey, but I've called it data. So when we run this, here it's cleared out, and we have our data set there. So now we can use it. So this first question again asks us to report a bivariate table for the relationship. So we can do that by using this bit of code called table. So if we use just the code table, it's going to create any kind of table we list, and I think it usually goes up to 2 variables, but we can also use it for 1 variable. So in my data set, I want to look at the breakdown of the exercise variable, which is exer. So I use data, which is the data set, $, and then the name of the variable. No, that's not what I wanted. Exer. And there we go. It's a table that shows how much people exercise. So 115 say frequently, 24 say none, they never exercise, and 98 of them say sometimes. We can do the same thing for our smoking variable, which is smoke. We say table, the data set, which is called data, $, and now we can specify the variable, which is smoke. Okay, run that. Here we see a table that says 11 are heavy smokers, 189 are never smokers, 19 occasionally smoke, and 17 regularly smoke. Great, now we have two tables. However, we're interested in how these frequencies break down by categories of another variable. We want to see how smoking relates to a person's amount of exercise, or in the case of your homework, how sex relates to the amount of smoking. Do frequencies of categories, frequencies of heavy smokers, never smokers, occasional smokers, and regular smokers, do those frequencies differ by someone's sex? So then we run the bivariate table. So we use that code again, table, data, and then I'm going to use my exercise variable, and then comma, my dependent variable, or the variable I'm interested in knowing about, which is sex, or sorry, smoke. I'm going to say data, $, smoke. And you can see that's listed up here as well. So I just typed it down here. So we can run that. Now we have a bivariate table with frequency of exercise on the rows and frequency of smoking on the columns. We see that people who frequently smoke, 7 of them say they're heavy, or frequently exercise are heavy smokers. We see that people who sometimes exercise, 84 of them are never smokers. So this is the simple bivariate table that I'm looking for. However, yours will be between sex and smoking, not exercise and smoking. I'm not going to do that here for you because it is a homework assignment, so you need to do that. So I will go. This would be my answer for my homework. I'm going to go into a new Word document. Say homework 3, Burroughs and Jr. Problem 1A. And I'm just going to copy and paste that table. And as we know, with any bivariate tables or any tables we have, we should probably give it a name. So I'll say, give it a name of bivariate relationship between amount of exercise and frequency of smoking. Cool. So we've done that question, now we're on to 1B. 1B is, what does it say? So second question, given the number of rows and columns in your table, report the degrees of freedom for the relationship between sex and smoking. For my example, I'm doing exercise and smoking, so it's going to be a little bit different. Now I say, given the number of rows and columns. And I say this because we discussed this last week when we're talking about calculating the degrees of freedom. So let's go to our course slides for chi-square test. Open that up and see what we say about the chi-square test. Calculating, nice, already there, degrees of freedom. So to calculate degrees of freedom, we need to know the number of rows and the number of columns. Degrees of freedom equals the number of rows minus 1 times the number of columns minus 1. So if you have 5 rows and 2 columns, it's going to be 5 minus 1, which is 4, and 2 minus 1, which is 1. So 4 times 1 is 4. So for a table that has 5 rows and 2 columns, the degrees of freedom is going to be 4. So now we know the calculation, let's calculate it ourselves. So Where is my R script? Let's go there. So to calculate the degrees of freedom, so yours will be slightly different because you will have different numbers of rows and different numbers of columns. But for me, I have 1, 2, 3 rows and 1, 2, 3, 4 columns. So I can do this. 3 rows, so 3 minus 1 times 1, 2, 3, 4 columns. 4 minus 1. Calculate that. So 3 minus 1 is 2 times 4 minus 1 is 3. So 2 times 3 is 6. So my degrees of freedom is 6. With the example earlier, I said we had a... So I'll go ahead and copy this first into my homework assignment. And we write it out like this. df equals 6. Very simple. In my example earlier, I said if we had 5 rows and 2 columns, our degrees of freedom would be 4. So if I go 5 minus 1 times 2 minus 1, we have degrees of freedom of 4. But for me, I had 3 columns or 3 rows and 2 columns. 3 rows and 4 columns, which led me to 6 degrees of freedom. Awesome. So that's the first or second question. Now, what is the value of the chi-square statistic? And that's where we actually calculate that. So here, I've written out the actual code for the chi-square statistic, which is CHISQ.test, so chi-square test. So basically, we use the same code that we did to run the bivariate table, but we replaced the word table with chi-square test. So I can highlight this. This will be our variables, except for yours, it will be sex instead of exercise. And I'll go here. And sometimes if you run the chi-square test, you run it and you'll get some error message, and it usually says the chi-squared approximation may be incorrect, and this is due to some correction factor that the test might have to do based on the number of cases that you have. But I would suggest ignoring it for the purposes of the homework. We don't get into much chi-square correction in this class, nor do you in many other classes, so it's not really something you should focus on unless you're going deep into the kind of rabbit hole of statistics. So we'll ignore that for now. But I ask in the homework, I ask you to report the value of the chi-square statistic, and the value is listed here. X squared equals 5.4885. So that is my chi-square value. I'm going to copy that and say 1C. The value of the chi-square statistic is chi-square equals, and I'll just go like this and hit, where are we here? Chi-square. There we go. The chi-square is listed there. Now, finally, I ask you to correctly and fully report and interpret the chi-square statistic. This means, using the example from our lecture, we have to include this chi-square value, the degrees of freedom, and the p-value. So if you look back to our lecture slides, I have an example which is updated. So in our example, we have the relationship between sex and whether or not a student says they are first generation. So non-first versus first, and men versus women. So we go through and calculate the chi-square, and we have degrees of freedom listed there is 1. Chi-square value is 57.99, and then we have to, and then when we use the back of the book, we find that our p-value is 0.001. I would suggest looking at this example to show you how to actually calculate it by hand. We'll run through it in class as well. So, because we're not calculating by hand, we're letting R do it for us. We report our values like this. Chi-square, just list the kind of statistic it is, chi-square. And in parentheses, you list the value of the degrees of freedom, equals, and then the chi-square value you just reported, comma, the p-value reported. So here, let's go back to our script. We have the chi-square value, we have our degrees of freedom, which we calculated earlier, it's listed there, and then our p-value. So if we open up our document, so 1D is going to be chi-square equals 5.4, actually it's chi-square with 6 degrees of freedom equals this, and then comma, p is equals 0.4828. Okay, and I'll go ahead. Now we've talked about p-values a little bit. So usually the cutoffs for p-values are things that we've been talking about in this class for a while. Our suggested p-values or alpha levels like give us the amount of error we're allowing, the amount of like the percent or proportion of time we're willing to be wrong, right? So if we have a 0.05 level, alpha level, that means that 5% of the time we're willing to say that our findings are wrong. Now if we increase that alpha level or make it smaller, it becomes more restrictive. So if we say instead of p or alpha equals 0.05, we're going to say alpha equals 0.01. That means we're only willing to say that we're going to be wrong only 1% of the time. We can increase that even further and say that our alpha level is going to be 0.001. That means we're only willing to be wrong 0.1% of the time. So it becomes more and more restrictive. So when you get a p-value of 0.03, that means you've reached a certain level of significance where it's smaller than our alpha level of 0.05. So we can say that the relationship is significant. Anything under 0.05 is going to be a significant relationship. So here we have our chi-square at 6 degrees of freedom with 5.48 is the level, and our p-value is 0.4828. So have we reached that 0.05 level of significance? No. This is because 0.48 is larger than 0.05. So what that means is we're likely to be wrong 48% of the time. So when you find a relationship that is greater than, where p-value is greater than 0.05, that means it's a non-statistically significant relationship. It's not statistically significant. That means, in the case of our chi-square test, that we don't reject the null hypothesis. Remember, we're always trying to test the null hypothesis, and the null hypothesis is that there is no relationship. If we get a significant finding, that means if our p is less than 0.05, that means we do reject the null hypothesis, and we say that there is a relationship between these two variables. With the chi-square test, we're always trying to say the null hypothesis. We're trying to show that the null hypothesis is there, and we're trying to disprove that. The null hypothesis being that these two variables are not related, aka they're independent. These variables are independent of one another. So we don't reject, we fail to reject the null hypothesis. We retain the null hypothesis because the p-value is greater than 0.05. So you can either write p is equal to 0.488 or p is greater than 0.05. However, when I say I want you to correctly interpret that, that means we have to go back to our interpretation. Here's the interpretation that I want you to use. So in our example, we were testing gender and immigration status. So we say using the chi-square test of independence, that's the first part, I either reject or fail to reject the null hypothesis that there is no relationship between first variable and second variable. And then you list those statistics we just calculated. So I'm going to copy this over. Actually, I'm just going to say, type it out. Using the chi-square test of independence, and because this is greater than 0.05, we fail to reject. So I fail to reject the null hypothesis. And what is the null hypothesis? That there is no relationship. That there is no relationship between our two variables. So my two variables are amount of exercise and frequency of smoking, comma, and then I can move this over here. This is where you report the chi-square value, and period. That is the appropriate way of reporting and interpreting the chi-square value. So for yours, you'd say using the chi-square test of independence, based on whether you reject or fail to reject the null hypothesis, you say I reject or fail to reject the null hypothesis that there's no relationship between sex and frequency of smoking, and then report your values there, whichever they are. Alright, that is it for that assignment. I would, hit enter a couple of times, create a new page, and that is where I copy all the contents of my R script, copy that, go back to Word, and paste that into there. So that's going to be my R script. And you can go ahead and turn that in, make it look a little bit prettier so I know where each homework or each answer starts, and then turn it in by submitting it online. Right, I'm going to save that desktop, homework 3, submit it, and you're done with the homework assignment. And when we return to class, I'm going to discuss chi-square a little bit more. We're going to go through how to calculate it by hand. We'll run through how to calculate it by hand and interpreting it. And then we'll get to the next topic of hypothesis testing. I think I'm going to post an online module for me talking about hypothesis testing, and then we'll run through that really quickly next week. The hypothesis testing as well, and I'll get to analysis of variance as well, which is just an extension of hypothesis testing and the t-test. So that is it. I wish you luck, and remember to submit this by 1 p.m. on Friday, May 5th. All right. Have a good one.